Find the number of recurring digits. Find the number of recurring decimals. Find the number of recurring decimals in first question 1 by 13. Second question 7 by for example 27 7 by 27. Third one if I see 5 by 12 5 by 12. Now, one by one we will discuss. If it is 13, answer will be number of recurring decimals, it will be factor of 12. So, answer will be either 12 or 6 or 4 or 3 or 2 or 1. I hope it is clear, right? So, in this case, let us do it 1 by 13. 1 by 13, 100 divided by 13. 13 sevens are 91, dot 90. 13 six are 78, again 12. 13 nines are 117, it is 30, again it is 2. 13 twos are 26. So if I can make it into most closest as 7.7%. 7.7%. I am getting 2 digits repeated. 7.692, it can be. All are most closest. It is not exact. So the number of digits will be 7.7. 7 by 27. Already we discussed. 27, it is 3 cube. So 3 cube into 2 by 3. So 27 into 2 by 3. 2 by 3. It is 18. Answer will be a factor of 18. Answer will be a factor of 18. That means it can be 1, 2, 3, 6, 9 or 18. Either 2 digits can be repeated in the answer or 3 digits can be repeated in the answer or 3 digits can be repeated, 6 digits. Multiple answers we are getting. I will tell you why it is 2. Just park it for some time. So, one answer will be 2 digits. Here the answer will also be 2 digits. Answer will be 2 digits. If I'll just tell you the answer in the next slide. 5 by 12. 5 by 12. Now if you see, 12 is 2 square into 3 power 1. 2 square into 3 power 1. This is a terminating decimal. This is a recurring decimal. Recurring decimal. Answer will be a recurring decimal. Answer will be a factor of 2 digits. We are not finding the how many digits, we are trying to understand the concept, how the percentage behaviors or the decimal behaviors will be there for fraction. 1 by 13, how many digits will be repeated in the answer? Could be in percentage or it could be in answer could be in percentage or it could be in decimal. First one, answer it is 2. We got 7.692. I approximated to 7. 27. I'll tell you why the answer is 2. So 27, it is 3 cube into 2 by 3. How many digits it will be repeated? P1 power k into 1 minus 1 by P1. 27 into 2 by 3. 18. Answer, the digits recurring will happen in factors of 18. 1, 2, 3, 6, 9, 18. 1, 2, 3, 6, 9, 18. Here the answer is 2. 12. 12 is a combination of 2 and 3. 2 will give you terminating. 3 will give you recurring. Terminating plus recurring. It is recurring. Terminating into recurring. It is also recurring. I hope the idea it is clear. Once we discuss fractions and decimals, I'll again come back to it. Just a glimpse of it I am doing. Why? Because I am converting fractions into percentages. Till where we did till here? Till here we did it. Now see here. 1 by 12. So recurring how much it will be? 3 into 2 by 3, 2. So answer will be 2 here. Sir, here 2 I got, here also 2 I got. So I will correlate both of them. So 1 by 9, 1 by 11, I did it. 1 by 10 is easy. 1 by 10 is 10 percentage. 2 by 10 is 20 percentage. So I will write down 1 by 12 and 1 by 13. Sorry, 1 by 12 and 1 by 17 I will write. 1 by 17. 1 by 13 I will write it here. 1 by 18, 1 by 19, 1 by 20 and 1 by 21. Listen carefully, sir. What are the prime numbers between 20 and 30? 1 by 23 and 1 by 29. 1 by 23 and 1 by 29. 1 by 24, 1 by 25, 1 by 26 and 1 by 27. And 1 by 27. These are the high frequency percentages which you will get it. Now there is a reason why I wrote like this, why I have drawn a lines. 1 by 12, 1 by 17, 1 by 12, 1 by 17, 1 by 12, 1 by 17, 1 by 17. 12 is recurring digits, it is 2. 17, it is 17 minus 1, 16. 2 is a factor of 16. That means 2 digits will get repeated. 12 goes how many times in 100? 8 times. Then the answer will be 8.33. This 3 is nothing but adding the digits in the denominator. Or you can divide 100 by 12. 12 goes 8 times in 100. Add the digits in the denominator. 17 goes 5 times in 100. Add the digits in the denominator. Add the digits in the denominator. 12. Number of digits repeated will be 12 minus 1, 11. 12 it is, 12 is a composite number. 2 square into 3 power 1. These terminating 3, it is 2. So the number of digits repeated will be 2. 3 is repeated. 17 is a prime number. 17 minus 1, 16. 2 is a factor of 16. Or simple language, 12 goes 8 times in 100. Add the digits in the denominator. 1 plus 2, it is 3. 3, 3. 1 plus 7, it is 8. 8, 8. 13 goes how many times in 100? 7 times. In the previous slide, I told you that it is 7.7. It is 7.7. So 1 by 13, it is 7.7 percentage. 13 goes 7 times in 100. 13 goes 7 times in 100. In case if you want a mnemonic, 13, there is a phobia attached to 13. That is triskaidekaphobia. 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 Tri is 3. Deca it is 10. Tri is 3. Deca it is 10. Phobia it is fear. Fear of number 13. Fear of number 13. Generally, Christian community, they consider 13 as an bad omen. Why? Because Jesus has got a lot of disciples. If I consider Jesus as number 1, the last disciple number will be number 13. His name is Judas. His name is Judas. So he is the one who is responsible for the crucifixion of Jesus. That is the reason Christian community do not consider 13 as a good number. They do not stay in house number 13. They do not have Scotland is one country. If you enter into the airport, they will not have gate number 13. Why Scotland? You go to Infosys Technologies, Bangalore. You will find building 1, building 12. Building 13, you will not find it. They do not stay in house number 13. They do not have an car plate number 13. They do not like to have their mobile numbers with 13 as few digits. 13. Triskaidekaphobia. 7 is considered to be a favorite number who wanted to get into a film industry. Amitabh Bachchan got his first super duper hit, 7th movie. And Amitabh Bachchan's entire life story is a classical example of a greatest failure turned into a greatest success. 1 by 13 is 7.7. 13. Triskaidekaphobia. Tri is 3, deca is 10. Phobia is fear. Fear of number 13. 18, 19, 20, 21. You can easily remember 1 by 20 is easy. 5. They all go together with a deviation of 0.25. They all go together with a deviation of 0.25. Again, it is 0.25 addition. It is 0.25 subtraction. So this will be plus 0.25 and here it will be plus 0.25. This will be minus 0.25. 18, 19, 20, 21. 5.5, 5.25, 5, 4.75. Simple index to remember. 1 by 20 is 5%. 1 by 20 is 5%. If the denominator value decreases, percentage value will increase. Increase it by 0.25. 18, 19, 20, 21. They all go together with a deviation of 0.25%. They all go together with a deviation of 0.25%. Similarly, 1 by 25 it is 4%. 1 by 25 it is 4%. They all go together with a deviation of 0.15%, which is 4.15, which is 3.85, which is 3.7. 3.7. 24, 25, 26, 27. They all go together with a deviation of 0.15. Simple index. 1 by 25 it is 4%. Go increase 0.15. The denominator value it is decreasing. So 1 by 27. Now see here. You can also remember like this. Divisibility rule for 27 and 37 are same. Divisibility rule for 27, 37 are same. Divisibility rule for 27 and 37 are same. So reverse also we can take it. 1 by 37 is most closest to 27. Now see here. Here very very important key point. 12. 12 contains 2 and 3. It is the most closest answer. Digital sum will not be valid if you multiply. 17 it is a prime number other than 2 and 5. These also most closest. 13 is a prime number other than 2 and 5. These also most closest. 18 it is 2 and 9. Most closest. 19 it is most closest. 20 it is 2 and 5 equivalent to. 21 most closest. Here it is most closest. 23 and 29 both are prime numbers. 1 by 29. 29 goes how many times in 100? 3 times in 100. You can write the first Pythagorean triplet. First Pythagorean triplet is 3.45. Interchange. If I interchange 3 and 4. I will get 4.35. Again, very very easy. You can use mnemonics to remember these fractions. Once you solve some hundreds of questions, automatically it will come into your subconscious mind. 24, 25, 26, 27. Easy value is 1 by 25. Remaining all go together with a deviation of 0.15. What are the prime numbers between 20 and 30? 23 and 29. Take 1 by 29. Take 1 by 29. 29 goes how many times in 100? 3 times. So write down 3.45. See here. You can easily calculate Pythagorean triplets like this, sir. How to identify Pythagorean triplets? Listen carefully, sir. How to identify Pythagorean triplets? Now see here. Take a take an odd number greater than 1. Take any odd number greater than 1. You can derive all Pythagorean triplets. Take an odd number greater than 1. 3. Square it. 3 square. 9. Divide by 2. 9 by 2. It is 4.5. Subtract 0.5. Add 0.5. Other two values you will get. Subtract 0.5. 4. Add 0.5. 5. 3, 4, 5. 3, 4, 5. 3, 4, 5 is a Pythagorean triplet. What is the next odd number after 3? 5. take odd number, square it and divide by 2. 25 by 2. 25 by 2, it is 12.5. 25 by 2, it is 12.5. Subtract 0.5 and add 0.5. 5, 12, 13. 13 square equivalent to 5 square plus 12 square. It's a Pythagorean triplet. What is a Pythagorean triplet? C square equivalent to A square plus B square. C square equivalent to A square plus B square. If it is 7, square it and divide by 2. 49 by 2. 24.5. Subtract 0.5 and add 0.5. Subtract 0.5 and add 0.5. Next one, 9. 9 square divided by 2. 81 by 2. 40.5. Subtract 0.5 and add 0.5. Subtract 0.5 and add 0.5. This is case number 1. Very, very easy way to determine if the lowest side is an odd number greater than 1. If the lowest side is an odd number greater than 1, you can find out the Pythagorean triplets by squaring the lowest odd number, dividing by 2, plus or minus 1. This case 1. Sir, what if it is an even number? What if it is an even number greater than 2? What if it is an even number greater than 2? Odd number greater than 1 I took, even number greater than 2. Suppose if it is 4, square it and divide by 4. Sir, why we are dividing by 4? It is an even number. Even number is of the form 2k. 2k whole square is 4 into something. That is the reason I am dividing. 16 by 4 is 4. Subtract 1 and add 1. 4, 3, 5. Subtract 1 and add 1. If it is 6, 6 square by 4. 36 by 4, 9. Subtract 1 and add 1. 6, 8, 10. If it is 8, 8 square divided by 4. 16. Subtract 1 and add 1. 8, 15, 17. Are you all with me? If it is 10, square it and divide by 4. 100 by 4, 25. Subtract 1 and add 1. Subtract 1 and add 1. 10, 24. 10, 24, 26. Even number greater than 2. If it is an even number, 4. 4 square divided by 4. 16 divided by 4. 4. Subtract. Here it is. Entire concept is plus or minus 1. Plus or minus 1. Here the entire concept is plus or minus 0.5. Here the entire concept is plus or minus 0.5. Why we are doing these odd now Pythagorean triplets? We got 1 by 29, which is 3.45. We got 3.45. Very, very easy to determine Pythagorean triplets. You don't need to mug it up. The lowest side, if it is an odd number, square it, divide by 2, plus or minus 0.5. If it is lowest, it is an even number, then it is plus or minus 1. Then what is the next thing? Next thing, it is derived. Derived means 3, 4, 5 into k. Put k value 2, I will get 6, 8, 10. Put k value 3, I will get 9, 12, 15. Put k value 4, I will get 12, 16, 20. Like that, k could be any natural number, any fraction and everything. You will get the derived triplets. Very, very important, sir. Extremely important. A foundation to entire geometry. If there is one concept where we spend about 6 to 8 hours only on solving on right-angled triangle related problems. I hope the idea it is clear. 1 by 23, it is 4.35. 1 by 29, it is 3.45. Is the idea clear? Now what I'll do is, I will just do a recap. In your examinations, these are some high frequency percentages. High frequency percentages are fractions. This is something which you are getting very, very highly repeated. A fraction will be of the form numerator by denominator. A fraction will be of the form numerator by denominator. Denominator 6, denominator 8, denominator 9, 11, denominator 4, 5, 4, 5, 3. These are highly repeated fractions. When the denominator it is 3, 4, 5, 6, 8, 9, 11. These are some things which are coming very, very important, sir. Very, very important. I will repeat some important key points so that students will understand the foundation level problems. A fraction will be of the form numerator by denominator. Numerator by denominator. I will get an exact percentage. Exact percentage. Or I will get the most closest percentage. Most closest percentage. Exact percentage when the denominator is only power of 2 or only power of 5 or both powers of 2 and 5. Both powers of 2 and 5. If the denominator is not derived from the only power of 2 or only power of 5, then it is the most closest percentage. Here you can apply digital sum. Here you can apply digital sum. Here digital sum cannot be applied. Here digital sum cannot be applied. Digital sum cannot be applied for the most closest percentage. Definitely it can be applied for an exact percentage. For an exact percentage. Extremely important. This you should know it. Otherwise you might do a mistake. Otherwise you will do a mistake. I hope the concept it is clear. First we discussed what are the things that we discussed. Numerator by denominator. Denominator, if it is a power of 2 or 5, I will get an exact percentage. How to derive Pythagorean triplets? What are the mnemonics to remember? 18, 19, 20, 21. Index is 1 by 20. 24, 25, 26, 27. Index is 1 by 25. 1 by 13. Triskaidekaphobia. Fear of number 13. 12 and 17. Cyclicity repeating it is 2, so I derived. How these three can be remembered? Add the digits in the denominator. 23, 29. 29 goes how many times in 100? 3 times. Write the first Pythagorean triplet. 23. Reverse the order. 23. It is reverse the order. I hope it is clear. So these are also not exact, most closest. Most closest. That is very important to me. Mathematically also we should be very, very right. Most closest. And these also will be most closest. I hope it is clear. Find the number of recurring decimals. Right? Using factor of p minus 1 concept. Using factor of p minus 1 concept. 13, it is a factor of 12. 27, from there you can derive. I hope the idea it is clear. First class is pure foundation, sir. If the foundation class only can be like this, where we are spending what teachers spend for 10 minutes. I'm spending close to almost 2 hours to explain how it is derived, so that you will not get a single doubt in simple interest, compound interest, and profit loss and discount. Profit loss and discount. I hope it is also clear. These also clear. So we did the basic high frequency percentage. We did the basic high frequency percentages. Basic high frequency percentages. Now derived percentages. A derived percentage is a combination of basic percentages. Basic percentages. What are derived percentages? Let us see. Let us do some more problems on derived percentages. Step by step only we will go. Once the concepts are clear. Derived percentages are derived fractions. or derived fractions. Question can be either in percentage or in fractions. Either in percentage or in fraction. Suppose if the question is 45 percentage. How can I write these 45 percentage from the basic percentage? 20 percentage plus 25 percentage. 20 percentage plus 25 percentage. These, suppose if the question is 31.11 percentage, these a derived percentage. These derived percentage comes from 20 percentage plus 11.11 percentage. 11.11 percentage. Suppose if the question is, all these I am going to use in my next few classes. 142.8571 percentage. This can be used as 100 percentage plus 42.8571 percentage. 100 percentage plus 42.85 percentage. I hope the idea it is clear. If it is 83.33 percentage, this can be written as 100 percentage minus 16.66 percentage. This is something which we know. This is something which we know. This is an unknown. Unknown is derived from the known. I hope the idea it is clear. Suppose if the question is, right, if the question is 34.09 percentage, these 25 percentage plus 9.09 percentage. 9.09 percentage. 9.09. Left hand side percentage is given. It is derived from the basic values. Similarly here fractions can also be given. 13 by 7. It is derived from 2 minus 1 by 7. 2 minus 1 by 7. Suppose if it is 23 by 9. 23 by 9 is 9 2s are 18. It is 2 plus 5 by 9. 2 plus 5 by 9. I hope it is clear, right? Suppose if it is, for example, 17 by 13. This can be written as 1 plus 4 by 13. It can be written as 1 plus 4 by 13. If it is 18 by 19, it can be written as 1 minus 1 by 19. These are all derived fractions. These are all base fractions. From the base fractions, we can derive the derived fractions. Suppose if it is 231 by 13, it is there. 13 ones are 13, 101. 13 sevens are 91. It is plus 10 by 13. 191, 221 plus 10 by 13. 10 by 13 can be written as 10 into 1 by 13. So from my next class onwards, either I can use a derived percentage or I can use base percentage. This is the derived percentage. This is a derived percentage, this is a base percentage. Derived fraction and how it is derived from the base fractions. I hope it is clear. Till here, the int and what to expect from a class. This is 1 by 2. I am adding fraction which is of the form 1 by 2. 4 by 8 is 1 by 2, right? What is the answer? 5 by 10. Again it is 1 by 2. Are you all with me? Beautiful concepts which we are going to discuss, sir. Suppose it is 3 by 5. Add the same multiple of 3 in the numerator, same multiple of 5 in the denominator. 3 3s are 9. 5 3s are 15. Same multiple. If you see, I got 12 by 20. 12 by 20 is 3 by 5. Are you all with me? Right? Suppose if it is 17 by 5. 17 by, for example, let me take 17 by 51. 17 by 51 is 1 by 3. Add the same thing which is of the form 1 by 3. 2 by 6. 19 by 57. which is 1 by 3. Are you all with me? Or the same thing, subtract it by 1 by 3. 17 minus 1, 17, these 51. 51 minus 3, 48. What did you observe from this? Whenever the values are like this, if I am adding the same multiples in the numerator and denominator, answer it is not changing. Answer it is not changing. Are you all with me? Tomorrow I will discuss in detail. Suppose I want to do 103 by 202. Most closest I have to do. Most closest. I will discuss in detail. Just I am giving a clumps. 103 by 202. 103 twos are 206. It is closely related to 1 by 2. Yes or no? So, what I will do is 103 by 202. Subtract 2 here, subtract 1. 102 by 200. Close to about 51%. I hope the idea it is clear. I hope the idea it is clear. Very beautiful way of solving this question, sir. 103 by 202. It is closely around 103 twos are 206. So it is closely in a multiples of 2 times. So if I decrease 2, I want the denominator to be a multiple of 10. If I decrease 2, I have to decrease 1 because it is of the form 1 by 2. It is of the form 1 by 2. I hope the idea it is clear. Suppose if it is 31 by 96, it is there. 31 3s are 93. It is closely of the form 1 by 3. If I subtract 6 here, I should subtract 2 closely. So this will become 31 by 90. Now the percentage it is easy. This we are going to discuss in tomorrow's class. This one thing which you will not find it in any regular textbook. Very beautiful observation from a fractions. It is of the form 1 by 2. Add anything which is of the form 1 by 2. See here, 1 by 2 plus 15 by 30. It is 16 by 32. Subtract anything of the form 1 by 2. It is minus 6 by minus 12. Again 1 by 2. Only thing what we want is this value. Observe the form of this number. Add some plus or minus k. We recap some important concepts. Yesterday we discussed the definition of percentage and we discussed equivalent fractions for percentages. We understood the difference between most closest and the equivalent value. We did fraction to percentage and percentage to fraction. And then we discussed any fraction will be of the form numerator by denominator. Any fraction will be of the form numerator by denominator if the denominator is a value which can be derived from powers of 2, which can be derived from powers of 2 or powers of 5 or both powers of 2 and 5 or both powers of 2 and 5, I will get the exact answer. Whenever exact answers are there, you can always use a digital sum to eliminate incorrect answer options. Only if the denominator is a derived value from the powers of 2 or the powers of 5 or both powers of 2 and 5, then we can use digital sums to convert the division into multiplication. If the denominator is not of power of 2 comma 5, is not derived from power of 2 and 5, I will get the most closest value. Most of the teachers will write 33.33 is equivalent to 1 by 3. It is most closest to 1 by 3. I hope you understood the difference between exact value and the most closest value. Exact answer and the most closest answer. Here digital sum cannot be used. It is extremely important for you to know which concept will be used when and which concept cannot be used and why it cannot be used. This is the second key point. Third key point, we did If the fraction is of the form numerator by denominator, we did for denominator 7, we did for denominator 11, 9, 12, 17, 13, 18, 19, 20, 21. What are the prime numbers between 20 and 30? 23 and 29. Then we took a quadruple, 24, 25, 26, 27. 24, 25, 26, 27. All these concepts, I used a concept. What is that concept? If the denominator is a prime number, if the denominator is a prime number, which is p, then 1 by p will always be a recurring decimal. Then 1 by p will always be a recurring decimal with a cyclicity of a factor of p minus 1. With a cyclicity of a factor of p minus 1. If the denominator is a composite number, if the denominator is a composite number which is of the form p1 power k, I will explain this concept in fractions and decimals. p1 power k into 1 minus 1 by p1. It could be a combination of either a power of a prime number or it could be a product of multiple prime numbers. These are some concepts which we discussed. First base percentage we discussed, then derived percentage we discussed. Percentage foundation we did it. Now based upon this one, let us do some important models. Listen carefully. The difference between percentage increase, percentage decrease. You should know these difference between percentage increase and percentage decrease. In entire class today, I am going to use percentage increase and percentage decrease. If you understand percentage increase and percentage decrease, then almost simple interest, compound interest, profit loss and discount, basic foundation is set. What do you mean by percentage? Percentage is, if it is 20%, this is equivalent to 1 by 5. 1 by 5. That means total, if it is 5 parts, total, if it is 5 parts. I told you yesterday that denominator is always the initial value. Denominator, it is always the initial value. I want 1 part out of 5 parts. This is the definition of percentage. This is the definition of percentage. First write down here, any percentage can be converted into a fraction which is numerator by denominator. Denominator always represents the initial value. Denominator always represents the initial value. Then what is numerator? I told you yesterday that I will discuss it in next session. Now I will discuss. This is percentage. What do you mean by percentage increase? The same thing we will write. 20% increase. Increase means positively it is growing. So 20% is 1 by 5. But there is a symbol 1 by 5 increase. 1 by 5 increase. What does that mean, 1 by 5 increase? Whenever you are doing percentage into fractions, denominator is always the initial value. That means initial value will be 5. Initial value will be 5. Initial value will be 5. Whenever I am doing percentage increase, the meaning of this 1 by 5 increase is, on 5 there is a 1 increase. On 5 there is a 1 increase. So numerator will correspond to change. If it is increase, it will be a positive change. If it is increase, then it will be a positive change. If it is a decrease, then it will be a negative change. If it is a decrease word, then it is a negative change. Positive change, then it is called increase. Then it is called increase. Negative change, it is called decrease. Write down in the same way, sir. Positive change is called increase and negative change is called decrease. Denominator is always the initial value. Then what will happen to the final value? Final value is equivalent to initial value plus change. initial value plus a change. Initial value it is 5, 5 change is positive. So final value is equivalent to 6. Final value is equivalent to 6. What is the difference between percentage and percentage increase? Percentage will tell out of total 5 parts, I want only one part. I want only one part. I want only one part out of 5 parts, which is 1 by 5. What do you mean by percentage increase? Out of 5 parts, I want one part more. I want one part more. That is a percentage increase. I want exactly one part out of 5 parts. That is 20%. I want one part more. The meaning of this statement is one part more on 5 parts. The meaning of this statement is one part more on 5 parts. The meaning of this statement is one part more on 5 parts. So final value will be 6. I hope it is clear. What are the classical examples of percentage increase? Profit percentage is a classical example of percentage increase. Markup percentage is a classical example of percentage increase. Rate of interest is a classical example of percentage increase. Now let us see percentage decrease. Percentage decrease. I hope it is clear to you. Each and every statement, listen carefully. Once the fundamentals are clear, then you will not fear solving any question. Percentage decrease. Without knowing the fundamentals, let us not get into problem solving. Percentage decrease. That means it is 1 by 5 decrease. 1 by 5 decrease. What do you mean by 1 by 5 decrease? It is one part less than 5 parts. Out of 5 parts, I want one part less than 5 parts. One part less than 5 parts. Whenever you are writing a fraction, denominator represents the initial value. Whether it is simple interest, compound interest, whether it is profit, loss and discount, whether it is time, speed and distance, whether it is time and work. You got a fraction, denominator represents the initial value. Denominator represents the initial value. So initial value. From now onwards, I will represent initial value as IV. Initial value it is 5. On 5, I want one less. So change is 1 less. 1 less means it is -1. So final value is initial value plus change. Final value is initial value plus change. 5 minus 1, it is 4. 5 minus 1, it is 4. What are the classical examples of percentage decrease? Percentage decrease. We can use a discount percentage is an example of percentage decrease. Loss percentage is an example of percentage decrease. Depreciation. Depreciation, it is a classical example of percentage decrease. Classical example of percentage decrease. Similarly, percentage increase. Percentage increase, what are the classical examples? Profit percentage, it is a classical example. Rate of interest, that is a classical example. Markup percentage, this is a classical example. So it is just that the namings are given to these percentage increase and percentage decrease. These percentage means exactly I want one part out of 5 parts. I want one part out of 5 parts. Percentage increase is I want one part more than 5 parts. I want something more. Then I will use percentage increase. I want something less. Then I will use percentage decrease. Then I will use percentage decrease. I hope it is very, very clear to you. One part out of 5 parts is percentage. One part more than 5 parts is percentage increase. And one part less than 5 parts it is percentage decrease. After the class, you will start looking at compound interest and a simple interest in a very different way and probably the easiest way. You will truly understand the power of thematic based learning once you start listening to the classes. Fundamentals are clear. Now we will solve we will write down this one. Suppose a percentage increase, it is nothing but numerator by denominator increase. Numerator by denominator increase. Now listen carefully. Denominator it is initial value. From now onwards, I will represent it as IV. Numerator it is change. Numerator it is change and it is an increase. So final value equivalent to initial value plus change. Why? Because it is percentage increase. Classical example. Instead of percentage increase, I will use profit percentage. Profit percentage is given by profit upon cost price. So what is the initial value? Initial value, it is cost price. What is the change here? Profit means I am getting more. Change is profit here. So what is the final value? Final value is defined as the selling price, which is cost price plus profit. I hope the concept is very, very clear to you. Percentage increase is replaced by profit percentage, which is profit upon cost price. Cost price is the initial value. I went to a shop. I purchased a pen at 10 rupees and I sold at 12 rupees. I purchased at 10 rupees. I sold at 12 rupees. What is the extra you got? 2 on 10. Extra change, that is defined as, right? Extra change. Exchange is nothing but final minus initial. So here, what is the change? You don't need to mug up any formulas, sir. So here, change is profit. Profit it is selling price minus cost price. Profit it is selling price minus cost price. This is one way of looking at it. Once we understand the foundation level, then probably solving problems will be very easy. This is one. Next one. Suppose, for example, rate of interest percentage. This is given by interest on principal. It is given by interest on principal. Suppose I did not had money. I went and took 100 rupees from my friend Praveen. Right? He said, Anil sir, you are using my money. You should pay me extra. That extra is called as interest. So initial value, it is always principal. In simple interest and compound interest, initial value, it is always principal. And change is interest. How much extra I am giving for using somebody's money, that is called interest. Initial value I took it is principal, change is interest. What is the final value? Final value in compound interest, we call it as amount. Final value is initial value plus change, so which is given by principal plus interest. So interest is given by amount minus principal. This is the beauty of thematic based learning. Once you know this concept, you can derive all the similar things under the same heading. Next one. Similarly, we have gotten another percentage, and that percentage is markup percentage. Markup percentage is, sir, what is markup? Suppose I went to a shop. For example, and I wanted to give this shield to somebody. There is no label here. I purchased at 300 rupees. I will put an ANC logo here and I will put the price as 500. I went to a shop. I wanted to give this memento to somebody. There is no label here. I purchased at 300 rupees. The purchased at 300 rupees, there is no logo. I kept my ANC logo and I priced it at 400 rupees. So the price marked on the product, the price marked on the product is called market price. The price at which I purchased the product, the price at which I purchased the product, it is called cost price. Purchased price or a cost price, both are synonyms. I repeat, purchasing price or a cost price, both are synonyms. Whenever I am explaining the class, in case if you are watching this class using your headphones, whenever I am reiterating the statements twice or thrice, I will repeat that statement because that statement has got a significance. Write down that statement in your notebook. Write down that statement in your notebook. What is markup percentage? Suppose I went into the shop. There is no logo. I purchased the memento at 300 rupees. So cost price. I attached my logo and I increased the price by another 200. So I increased it. To get the market price, I may increased it. Increase is upwards. I wanted to have an MP which is greater than CP. Again, I am repeating it. I wanted to have a market price greater than cost price. So I made the value little higher. Up is increase. To get the market price, I increased it. To get the market price, I increased it. Therefore, the name markup. Therefore, the name markup. So, initial value it is cost price. Change is markup. Change is markup. 300 rupees is the cost of the memento. I made it to 500 rupees. So what is the difference? Difference is 200. What is that difference? Difference is actual cost price is 300. I made it into 500. So what is the final? Market price will become on cost price, I increased the price. So cost price plus markup. Cost price plus markup. I hope these three are very, very easy to you, easy to understand. The basic foundation is this point. From this point, these three concepts are derived. First concept, second concept, and third concept. Are you all with me? We will solve more and more examples so that you will understand this concept in detail. Example 1, 2, 3. One more example. We did not only percentage increase, we did percentage decrease. We did percentage decrease. We will write down this one. Percentage decrease. Converting into fraction, it is numerator by denominator. It is a decrease. So, denominator is always the initial value. Denominator, it is always the initial value. Numerator corresponds to the change. Change is negative here. So, the value will go down. The value will go down. So, answer is, final value is initial value minus change. Final value is initial value minus change. Is the idea clear? On initial value, the value is going down. One part less than 5 parts. On 5 parts, 1 part less. So final value will be 4. This is the foundation. Based upon this foundation, some key values are given. The first one, it is loss percentage. Loss percentage. I went into a shop, purchased a product at 10 rupees, but while giving it to my friend, I gave it at 8 rupees. So loss by CP. Decrease. Initial value, it is cost price. Loss is nothing but the change. Change is negative here. Change is negative. Selling price equivalent to cost price minus loss. Selling price equivalent to cost price minus loss. You don't need to remember anything. Just an idea I am giving it to you. The next one, it is discount percentage. Discount percentage. I went to a shop and there is a price marked on the product. There is a price marked on the product, which is marked price. There is a price marked on the product, which is marked price. There is a price marked on the product, which is marked price. On that one, suppose I went and bought a water bottle which cost 20 rupees. My friend said, can you give that water bottle? I sold it at 15 rupees to respect the friendship. So selling price is on initial value markup, there is a discount. Selling price is marked price minus discount. Selling price is marked price minus discount. Is the idea clear? Discount percentage is discount on marked price. I bought a water bottle at 20 rupees. I sold it at 15 rupees. So the discount which I gave, what do you mean by discount? Discount is the money lost because of friendship. There is another important keyword that will come in simple interest, compound interest, that is depreciation. Depreciation. The value of a dollar went down. Initially you purchased a course at X rupees. Because of the market trend, that value got down. That is a depreciation. What do you mean by depreciation? Suppose I took money from my friend 100 rupees, and after 1 year I am unable to give. After 2 years I am unable to give. He came and said, hey, don't give me 100 rupees, give whatever you can. So the value which I took got depreciated. The value which I got, it got depreciated. So this final amount is principal minus depreciation. Final amount is principal minus depreciation. Suppose you took money from somebody, you are unable to pay, and the time period is flowing by. That person will be frustrated. He will initially scold you. He will initially keep you sending a lot of messages, but after 1 or 2 years he'll be vexed up. Instead of getting X money, give me 0.5X and finish this one, because he feels that you are giving a stress to him and you are killing his peace. So this is what is important to me. For me, if I understand this, I can derive a lot of things. Again, I am telling you this important key point. Make a note in your notebook. What is that one? Percentage increase. What are all the examples of percentage increase? Profit percentage is an example of percentage increase. Rate of interest is another example of percentage increase. Markup percentage is another example of percentage increase. In a percentage decrease. These are the three examples: loss percentage, discount percentage, and depreciation. Loss percentage, discount percentage, and depreciation. Now if you see here, so if I take a ratio numerator by denominator, if I take a ratio which is numerator by denominator, now see here, right? So there can be an increase or there can be a decrease. There can be an increase or there can be a decrease. Increase, it is profit percentage. Increase, it is markup. As the name says, I am increasing the prices. To get the market price. And ROI, rate of interest percentage. These are the three examples. Here, loss percentage will come. Here, I am losing money, which is a discount. Discount is the money lost because of friendship. Then depreciation. I could not get what I gave, so I got little less. So based on increase, there are 3 percentage values. Based on decrease, there are 3 percentage values. It's very, very easy to understand the entire chapter. Now if you see here, profit, loss, and discount, this entire chapter I will write down in one table. The price at which I purchased the product, which is cost price. I went to a shop and purchased the product, which is cost price. The price at which I sold the product, which is a selling price. What is the price marked on the product? Which is a selling price. What is cost price? purchased price, the price at which I purchased the product. What is the selling price? The selling price. Marked price. What is this marked price? Price marked on the product. Price marked on the product. Price marked on the product. Now if you see, only there are three prices: cost price, selling price and market price. Suppose I call this one as 1 and I call this one as 2 and I call this one as 3. So there are three prices are there. If I select any two, 3C2, which is 3C1, 3 ways. 3 ways I will get. So if I do 2 minus 1, 2 minus 1, I will get a profit. Are you all with me? If I do 3 minus 2, if I do 3 minus 2, I will get a discount. I will get discount. If I do 3 minus 1, I will get a markup. Finish. This is your entire profit, loss and discount. This is your entire profit, loss and discount, which is 2 minus 1. Here it is 3 minus 2. Here it is 3 minus 1. 3 minus 1. I hope the idea it is clear. I hope the idea it is clear. There are three prices in profit, loss and discount. You went to a shop, you bought a product which is cost price. You went to a shop and you saw a product and there is a price marked on the product. There is a price marked on the product which is a selling price, which is selling marked price. And you sold a product to a shop which is selling price. Cost price it is 1, selling price it is 2 and market price it is 3. 2 minus 1 it is called profit. 3 minus 2 it is called discount. 3 minus 1 it is called markup. Entire profit, loss and discount. Three prices are there. Select any two. 3C2 which is 3C1. There are 3 percentages which I will get: profit, discount and markup. If you get negative here, loss is nothing but a negative profit. Loss is nothing but a negative profit. A profit value which is negative. I hope the idea it is clear. I hope the idea it is clear. Similarly, in a simple interest or a compound interest, in a simple interest or a compound interest, if you purchase the product, it will become initial value. If you sold the product, it will become final value. So what are the three things that we require? Initial value we require, final value we require, and change we require. Again I am repeating, whenever you are solving a percentage problems, initial value you require, final value you require, and change you require. Initial, final and change. Initial value, it is called principal in simple interest and compound interest. Change, it is called rate of interest. Final value, it is called amount. Final value, it is called amount. Principal, rate of interest and amount. Because I take money from somebody, how many years you took? I took it for 1 year, I took it for 3 years. So the change, that is the difference between simple interest and compound interest. So based on the time period, based on whether it is done on a simple interest or on a compounding, then 2 chapters will come. Then 2 chapters will done. Whether the rate of interest is the same every year, then it is SI. Rate of interest changes every year, then it is compound interest. Banking uses compound interest. Banking, all these finance companies, they use these compound interest. I hope it is clear. The more you delay the payment, the more rate of interest you need to pay. I hope the foundation, it is clear. Till now we discussed difference between percentage increase and percentage decrease, and the various values which are derived from percentage increase and percentage decrease. Now we will solve by using thematic based